All right, so quickly, we're not going to get through all this stuff. Let's maybe I want to review a couple linear systems problems, really just one. And then we'll jump into the next topic. We are going to jump around a little bit, by the way. So in Unit 4, like in your textbook, we're going to skip through 4.2 and 4.3, jump up to 4.4. I'm going to show you guys some stuff that's not really in the textbook, some technology ways to solve big linear systems. It's some different applications of linear systems. By the way, solving linear systems is a highly applied part of mathematics. This is stuff that if you're not a math major, you still will end up doing in college. If you go into a math-related field of any kind, linear systems is going to be something that you will continue with. So using technology to solve these things is really useful. So that's going to be, I think you'll like that section. Okay, so how about this? What about a problem like this guy? Okay, and I picked this one because it's got some fractions in it. I want to help you guys just not panic when you see fractions. Not that you did, but I heard from a lot of people, oh my gosh, is that right? I got a fraction. It must be. No, you can get fractions as answers. Fractions are numbers. So how do we solve this system? And they tell us to solve by elimination. But before we use elimination, give me thumbs on this. Could you apply substitution method on this one? Thumbs up or down? Definitely thumbs up. Yeah. How come? What makes this a substitution a good candidate here for I've got coefficients of 1 or -1, right? So I've got a coefficient of 1. The x's coefficient in the bottom equation is 1, which makes that x easy to isolate. The coefficient of x in the top equation is -1, which makes that one easy to isolate. Okay, at this point, let's click everything closed. I want earbuds and all that stuff away, phones away, please. Okay, so let's use elimination, though. They tell us to use elimination. What do I have to do to solve that system by elimination? Say it again. Okay, so in other words, I have to do nothing to prepare this for elimination. It's already set up for elimination, isn't it? I can already just add those equations together to eliminate the x's, okay? So if we do that, if I add these up, the x's cancel. 6y plus y is 12y. 7 plus 14 is 21. Good. So if I divide through by y or by 12, I get y by itself. Now we can reduce that fraction too. 21 over 12, I could divide each number by what? By 3, yeah. So 21 divided by 3 is 7. 12 divided by 3 is 4. So I'm halfway there. Y is equal to 7/4. Okay, now what? Okay, good. Plug that. That's my y value. I'm going to plug in to either one of my original equations, whichever one looks easier. What do you suggest? Top one's fine. We could do the top one. I might do the bottom one, honestly. It'd be almost the same, but why the bottom one? Good, because the x is it's easier to isolate. It's easier to solve for x, right? Okay, so let's use the bottom one. Again, not that it really matters all that much, but we'll use the bottom one. And what do we get then? So we get x plus 6 times my y value, which is 7/4, equals 14. Okay, so what am I going to do here to find x? Okay, I got to distribute, meaning I have to multiply, right? Okay, so there's one issue. Now let's make sure we all are comfortable and this makes sense to us. When we multiply numbers, if one of them is a fraction, we just make them both fractions and multiply straight across, right? So that's going to give us x plus 42 over 4 equals 14. Okay, we should reduce the fraction to make our lives easier there. Can I reduce that? I could divide top and bottom each by by 2. If I have even numbers, I know they're both divisible by 2, right? So divide each by 2, and that's going to give me x plus 21 halves equals 14. Okay, now what? What are my options? Okay, I could subtract 21 halves from 14. That's fine. If I do that, I've got to subtract fractions, get a common denominator. That's okay. What's another option? What do you mean divide? Okay, so now the suggestion is if I divide, you mean get a decimal? Okay, that's fine, except if I get a decimal that's not terminating, that makes it tougher, right? Because then the decimal goes forever and I have to round it, and that can cause problems. So I would advise actually not making it a decimal. Okay, I could subtract 21 halves, which is fine, or I could clear fractions, right? I would say in general, I think clearing fractions is not a bad way to go. If I just distribute a 2 through the whole thing, because that's my only denominator, what happens? Well, 2 times x gives me 2x. 2 times 21 halves, oh my goodness. Boy, I really talked a lot today, didn't I? Okay, we'll finish this up tomorrow.